Good morning to all. During the last class, we have studied about matter and which materials particles are made up of and the properties of the particles. Today, we are going to study the states of matter. The states of matter. When we saw a thing, unknowingly we say that it is a solid or it is a liquid. Now, I can show something. This is a duster, this is another thing, this is another, this is a stone, this is a spoon. These are several things. What are these? These are solids. Solids. What are the properties of the solids? We can see that one, we can find out the volume, length, breadth, and height. It has a definite shape. It has a definite shape. It has a definite volume. It has a definite volume. We can calculate the volume of this. We can calculate the volume of this. All this volume. This is stone. It has also a definite shape. Though it is irregular, we never mind it has a definite shape. These are the different the properties of a solids. Why? Now we can say why these have these peculiar properties. We can find the area of this stone also. How it was put into a beaker containing water. By Archimedes principle, when it is put into the water, it displaces the water which is equal to the area of the stone. So, these are the main properties of the solids. What are they? It has a definite shape, definite volume. It is rigid, not like fluids. It is rigid. We can say anything. The solids are rigid. The other thing is solids are incompressible. We cannot compress it. We cannot compress it. It is incompressible. What is research? Why it is got in these properties? One more thing is this in solids, the particles, we have already learned that all substance, all matters are made up of tiny particles. In solids, the tiny particles are very close. They are tightly packed. Their distance between the molecule is very small. Or it is negligible. In the case of solids, the distance between two tiny particles is negligible. So that is incompressible. We cannot compress it to a small size. It is incompressible. So another thing is the kinetic energy. It cannot, in solids, the particles cannot move. So the kinetic energy is very small or no kinetic energy. It has distinct boundaries. Anything you take this pen, it has distinct boundaries. It cannot change the boundary. It has also distinct boundaries. But in the case of, we can compare it to other thing, the case of liquids. Which have already heard the case of solids. Here, 100 ml water is taken. Water is a liquid. First, we have to find out whether it has a fixed shape. When the water is taken inside the beaker, it takes the shape of the beaker. Here it is actually the water is 100 ml. 100 ml water is taken. It is put into another bottle. Now you have to notice two things. First, the volume. In the first beaker we take 100 ml water. It is poured into another bottle. Its volume is now finally you can notice. It takes the shape of this. Then this 100 ml water is poured into another conical flask. It takes the shape this. This water is again poured into a measuring flask. The volume does not change. Initially we take 100 ml, finally also it is a 100 ml. So we can came to a conclusion. What's the conclusion? Liquids have a fixed volume. Liquids have a fixed volume, but not fixed shape. The liquids always takes the shape of the container. In which bottle or which place we take it, the shape of the water is the shape of the container. But we have, comparing to the solids, it has no definite boundaries. The boundaries are like in which bottle it is situated. So this is the main two properties of the liquids. The liquids are one, the liquids it is fixed, no fixed shape but fixed volume. It is not rigid. In the case of solid, it is rigid. In water, it is not rigid. Now we can, comparing to the solids, we can note down the properties. One, the liquids are no fixed shape. Shapes depends upon the container which is taken. It has a fixed volume. A container is taken, finally also it's a container. It is fluids. The next thing you have to notice is whether these liquids are compressible. We have to, the liquids what is taken, we have to try to compress it. The liquids are least compressible, it is not compressible. If we can compress, there is a change in the level, but not liquid is compressing, but the compressing is on the air, the top of the bottle. Liquids are not compressible. At least you can say the liquids are comparing to the solids is not compressible, liquids is least or negligible compressible, or we can finally say liquids are not compressible. It has no fixed boundaries, it is fluids. When we can see go to the other experiment, the third state of matter is gases. Gases. Solids, liquids and gases. Here, a bottle containing oxygen. Oxygen is filled inside. Gases are invisible. Colorless gases are invisible to the eye. If the colored gas is filled, we can see. What is colored gases? Whether it has a fixed shape. No, the gases does not have a fixed shape. Here, air is filled inside. It does not have a fixed shape. We can make any size by pressing it. It has no fixed shape. Other thing is, it has no fixed volume. It has no fixed volume. The gas, it fills the container whether it is occupied. We have put some oxygen to it and the oxygen fills the container. The oxygen fills the container always. If we put some air, is always they are filled the containers. It is so the gases are not rigid, no fixed shape, no fixed volume, no distinct boundaries. and at the same, it fill the container where it is taken. It has no fixed boundaries. It fill the container where it is fluids. It can flow from one bottle to another. It can easily flow from one direction to another, one place to another, one bottle to one kind of container to other container. So, comparing the properties of the solids, liquids, and gaseous solids. One more thing is the solids does not fill the container. If a solid is placed here, it is okay. It does not fill the container. It has spaces. At the same likewise, the liquids also does not fill the container. It has a level. It does not go to it. If we 100 ml liquids, it is only 100 ml. At the same time, we take a gas. We take 100 ml oxygen into this bottle. It fills it. So the one more thing is we have to notice is can fill the container. Yeah. Solids do not fill the container. Solids do not fill the container. If an ice cream ball is placed inside the bottle, it has a mixed bottle. It will not fill it. If mango juice is taken inside it, it has the level of the quantity, not fill the container. At the same time, any gas is taken, it fill the container. Now we can see it, one more example. Let us do another experiment. It is familiar to you and familiar to all things are in your form. You can observe this and you can do it in your form. What is this? This is ice flakes. This is ice flakes. In which state it is? In solid state, ice, solid state. What is this? This is water. Water, the liquid state. Do you know what is coming up first? Water vapor. But ice, the solid state. Ice, the solid state. Water, liquid state. Water vapor, the gaseous state. Now must we notice the difference in the state. Then we can also apply what we have already read the properties. This is solids. This is solids. What does it? It has a definite shape, definite volume, rigid, not compressible. It does not fill the container. We can from the area of it. At the same time, water, it has a fixed shape. It has not a fixed shape. It has a shape which is it contains. It has the volume is fixed. The volume is fixed. It is fluids, not rigid. And at the same time, it does not fill the container. For solids, liquids, and look at the gaseous state. They are not rigid, and if you collect in a tin, it fills the container. Not rigid, it fluids. It's like fluids. Flow from one direction to and the other direction. For water properties of the gases, not rigid, no fixed volume, no fixed shape, fluids, and it is compressible. If the collection in and press it, we can press it in different shapes. So these are the main points. You can compare with this, then you can never forget the quantities of solids, liquids, and gaseous. Then we can go to the other reason. Why water can exist in the three states? Ice, water, and water vapor contain same kind of particles, same kind of tiny particles. When ice on heating, it melts into water. Water on heating, but it boils and go to process. The temperature at which ice melts is called and from water is called melting point. The temperature at which ice melts is called melting point. The temperature at which water changes into water vapor is called boiling point. Now the boiling point is You can notice 100 degrees centigrade. Water boils at 100 degrees centigrade and water turns to water vapor. This boiling is also known as vaporization, not called as evaporation. Vaporization and evaporation are entirely two different processes. If you do not confuse each other, this process is known as vaporization. What do you mean by vaporization? Changing liquid state to gaseous state. It is vaporization. Evaporization entirely other process we can study later. Likewise, liquids. Solids into the liquids is melting, and the process is known as fusion. Why this happens? In solids, we can notice one more thing. The distance between tiny particles is very small. The distance between the tiny particles of solids is very small. At the same time, the distance between the particles in water is greater. At the same time, the distance between the particles of water vapor is very great. In the case of attraction, in solids, the particles are close very much, right? Force of attraction between the particles in solids is very great. But the case of force of attraction in liquids is comparing to the solids less than. And the force of attraction is no force of very less, or the force of attraction between the gaseous state is least. Then the other one thing you have noticed is the kinetic energy. Here you can see that the water vapor is moving quickly. This is due to the kinetic energy possessed. In solids, the kinetic energy of particles is very little. It cannot move. It can only vibrate their position only. The compared to the kinetic energy of solids, the kinetic energy of liquids is great. The particles of the liquids are greater than the solids, or minimum intermediate between solids and gases. The kinetic energy, force of attraction, all are intermediate between solid state and gaseous state. The kinetic energy of the gaseous state is very high, so it can move freely from the in the atmospheric state. Please notice what we have seen these activities. In the case of solids, liquids and gaseous state. When we are going to study this, the point, the thing came to your mind is ice, water and water vapor. Then you looking to our scientifically, you see the ice. It has a definite shape, it is rigid, it has strict boundaries. Any solid substance, not ice, you are not on lakhs of things in your surroundings are solid state. Any solid state you take it has a clear boundaries. It is not compressible. It is not compressible. It has definite volume and it do not fill the container. We have already seen that when a solid phase is in the water, then yes, they are not fill the container. But in the case of liquids, for example, water, in your home you can take a number of liquids, for example, coconut oil, cooking oil, vinegar, etc. liquid state, the matter liquid state. All these liquid states have and these properties, no definite shape. The shape of the liquids depends upon the container which it occupies. It has no definite boundaries like stone or any other sphere or any other thing. It are fluids, not rigid. Liquids are fluids. It's not compressible. Negligible compressibility means not just not compressible, incompressible. We have already seen the reason for it. They are definite volume. You have seen that a 100 ml water is taken a 100 ml and pouring into different vessels, and then as a 100 ml volume does not change. It do not fill the container. At the same time, Gaseous state has no definite shape, no definite boundaries, just fluids, it is highly compressible. We can know that the shape of a balloon can be compared to an apple, and you put any shape, you can convert it. Then it is highly compressible, no definite volume in the container. For these three states, you always came here while you are eating breakfast or evening tea. While you are taking evening tea, in one can, what is it? In one can, you have biscuit, the other can, hot water. There we can already notice that there are three things: biscuit, the solid state, water, the liquid state. Inhaling, you are absorbing, inhaling and exhaling the air in the gaseous. We every day, we have already said that every action you notice, you have seen the things through your sighting gate. You take in tea, the evening tea, the liquid stage, puffs in the solid stage, and always you are breathing air is in the but air is in the gaseous state. So these three states. Then you have to notice only these three states. Why these are the what properties? Due to the arrangement of all this cause. This is one word. Why it have a different shape or rigid? We can use in a single word. It is due to the difference in the arrangement of the tiny particles. Then we can notice one more thing. We have already read that the kinetic energy is the energy possessed by the particles by the movement. The kinetic energy is very less or is very least. In the case of gases, it is minimum, it is maximum. And in the case of liquids, it is intermediate between. It is intermediate between gaseous, solid state and gaseous. The kinetic energy possessed by the molecules of the solids are very least. They can't move from one place to another. They are fixed. At the same time, it is in the case of liquids, it is intermediate between solid, liquids and gaseous state. And the kinetic energy of the gaseous state, the kinetic energy of the particles are very great. Similarly, the distance between the particles. In the case of solids, they are closely packed. The particles are closely packed. There is no gap between the particles. Distance between the particles they are closely, tightly packed. But in the case of liquids, there is some distance between the particles. Some distance between particles is great. This is in the case of liquids. But in the case of a gaseous state, distance between the particles is great. These are the arrangement of the particles. Arrangement of particles in solids, liquids and gaseous. Today, after seeing the glass, take ice, water and water vapor, then take a drawing paper and draw the distance between the particles. Then the force of attraction. The force of attraction is great in solids, minimum in liquids and least in gaseous state. Then we can represent it by another simple idea. You consider these fingers are considered the particles. Let us take after studying this, after seeing this episode, you can imagine your fingers are the particles. And what is the shape of how the particles are arranged in solids? They are tightly packed. The solids they are tightly packed. They are solids. They are tightly packed. They can't move freely from one place to another. They can't move. They can only vibrate their own place. This is the solid state. But in liquid state, they can slip from another. Not freely. In liquid state, the particles are always this. They can slightly move them. They are not freely. But the gaseous state, they are completely free. This is then you have a doubt by taking class. You have to adapt this. You do themselves. This state, you never forget it. What is the shape? What is the arrangement of particles in solids? In solids, the tiny particles are closely packed. Closely packed. There is no distance between the particles. No distance between the particles. The force of attraction is very great. In the case of liquids, they can slightly move. So there is distance, some distance between the particles. The force of attraction, comparing towards the force of attraction is less. But in the case of water molecules or gaseous water vapor molecules, what is again the molecules are completely free. They can move each other. The kinetic energy is great. The distance between the particles are. So after reading the passage, with your hands, you can explain all the properties and find this arrangement. The properties are due to the arrangement of particles. You can prove it yourself and you will never forget it. Yeah, and you can show it to another. You can make bet between your friends and you can get a clear idea about solids, liquids, gaseous state, melting point. Melting point and the process. Melting point is the process of changing solids to the temperature at which the substance change from solid to liquid state. That process is, temperature is known as melting point, that process is known as fusion. Likewise, boiling point is the temperature at which in a substance, a matter changes from liquid state to the gaseous state. That temperature is known as gaseous boiling point and the process is known as vaporization. Okay, thank you all. We can see the next class.